If we look at some definitive terms, and when I say that, I do literally mean terminology, cloud computing in and of itself is a little bit difficult to define, simply due to its evolutionary nature. It's continually changing. The way that any cloud service provider looks today might be significantly different a couple of years from now, simply because it does change so rapidly. But that being said, there is a loose definition that was put forth by, you see here, the National Institute of Standards and Technology, or NIST. And this is an organization that's been around for quite some time. But their definition states a model for enabling convenient, on demand network access to a shared pool of configurable computing resources such as networks, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. That is a fairly convoluted definition, to say the least, but the key behind it is simply the fact that any given organization has whatever infrastructure in place to meet their needs. If that infrastructure is robust enough, then not only can they meet their needs, they can also meet other people's needs. And a simple example of this is if you think about websites. Let's say that you have an organization and you have a web server. You can obviously host your website. Perfect, great, that's no problem. But if it's a fairly simple website and it's not really very heavily taxed, well, obviously you could host another website on that same server. So maybe a very simple example, you have a friend who wants to also have a website. Well, you can say, I have a web server. Let's put your website on my server. And if it's, maybe another business, you might charge them a bit of a fee for that. That, in essence, is a cloud service because the site itself resides on a server that is physically separate from this other person. They access it over the internet. They use standard FTP or any other method for updating the site. But all they have to do is simply access it from wherever they are, make their updates, make their changes. They don't really care where the physical server is, and they simply pay a subscription fee each month to be able to continue to have that website up on that server. That is, in essence, cloud computing. All of the resources reside with someone else. They simply pay for access to those resources. And again, it's very quick, very easy for them to put up the website. From that point, all they need to be concerned with is the management of the website itself. They will rely on you to keep the server secure and up to date, patch the operating system, upgrade the applications, things like that. Make sure that the security software is maintained. So, again, you alleviate those concerns from the customer. You just say, here's some space on my web server. Go ahead and post your site. We'll worry about everything else. That's the basis behind cloud computing. So the term itself, cloud, makes reference to two concepts at the end of the day. This abstraction, which is a process in which specific details are hidden or ignored to simplify or generalize something. And the website that I just spoke of is a perfect example of that in the location of the server. The customer does not care, or at least should not care, where the physical server resides. They are accessing it over the internet. So it doesn't matter where they are. It doesn't matter where the server is. So there's no reason for that to really even be considered. So we abstract that. And virtualization, the process in which software manages hardware resources of physical hosts, so those resources can be used more efficiently by multiple virtualized guest systems. So again, coming back to my website example, maybe you want to separate your customer's website a little bit more from your server. Well, it is quite possible that your website is running on a virtual machine on one of your physical servers. Well, it's up to you, but you could have the other person's website running on that same virtual machine, or you could create a separate virtual machine and then host their site on that. So again, this actually pulls in two concepts: the abstraction, wherein if their site is running on a separate virtual machine, why does it matter to them? It doesn't matter to them. So again, we see abstraction, but we also see the virtualization. I can spin up as many virtual machines as are necessary to host the websites or the applications or whatever it is for my clients. And again, it allows them to be separated off into their own little world of their virtual machine so that they can do whatever they want with that virtual machine. I'll look after the physical system itself and maintain the hardware, make sure it's kept secure, make sure it's kept up to date. They do not have to worry about that. So, the whole concept behind the cloud computing, again, is to abstract not only the details of certain things, but the tasks that are involved. Things like the management and the upgrades and all of that are removed from the customer. They need only concern themselves with the service they need, and that's it. So, abstraction and virtualization put together make up the essence of cloud computing. Let's begin with a little bit of a history of cloud computing. And it's something that actually goes back quite a ways, all the way back to about 50 plus years with respect to the technological advancements that have led to what we now know as cloud computing. But back in those days, we had standalone mainframes back in the 60s, you see here. And the idea behind the mainframe was that everything that you were doing in your environment ran on the mainframe. So your client systems that we think of today, such as a desktop computer, really didn't do anything. All they really had was a keyboard and a screen that would attach them to the mainframe. So every application, every service, absolutely everything that any person was doing in front of a terminal, as it was known, was actually happening on the mainframe. So these were just literally, the term was dumb terminals because they did not have any processing. They were just really long extension cords, if you will, for a keyboard and a monitor back to the mainframe. But this did support early virtualization in those mainframes up around the 70s. And this was the ability to run a system within another system, if you will. These days, we talk about virtual computers, virtual machines. This is really the same idea. It's one single collection of hardware that is able to run more than one installation of an operating system or an application, and that support as has actually been around for quite some time. So, despite the fact that there was this early virtualization capability, there started a progressive shift from this centralized computing, which again was everything running on the mainframe, to a more client-server type of system in the 80s. This is where we had smaller systems because mainframes were physically very large, took up a lot of space. So a few more smaller servers were introduced wherein we could store data and basically access the information that we needed from those servers. But we could run the programs that we wanted to run on our desktop computers. So applications no longer ran on the mainframe. We were able to install software on our own desktop computers, so we no longer had a dumb terminal. Our systems were able to do the processing to handle the workload of running that application. It was simply the data that we needed to access that resided on the servers. So that's the standard client server model, and of course that was very widespread throughout the 80s and into the 90s. And then it went even a bit further in the 90s into what was known as distributed computing, wherein now not only is the application running on maybe a particular single system or server, it's running across several systems or servers. So things like database applications, for example, would be spread across multiple servers to distribute the workload a little bit more effectively so that we can gain better performance and have scalability. So that was the idea of distributed computing, an application that ran across multiple servers as opposed to just one, or of course on a centralized single system. And this, of course, was the beginning of the internet era as well. So that brought us to the point wherein we were able to access applications as a service over the internet. So in the late 90s, we started to see this. One of the early examples was distributed customer relation management software. So the whole idea now is that the application is not even running in your own environment. So it went from centralized on the mainframe to a client server model to distributed across multiple locations, but those multiple locations were still under your control in your organization. Offering it as a service means that the vendor themselves or somebody else that is simply reselling it, they are running the application and you simply access it over the internet. So, in essence, you can subscribe to the services that are provided by somebody else. And again, these distributed customer relationship management software were one of the early examples. Now, this also introduced server hardware virtualization over the internet. So again, not only could we access applications, but we could actually access the services offered by various hardware, networking components, firewalls, for example, things like that could also be accessed over the internet. So that ultimately brought us to the rise of cloud computing. Now, cloud computing in and of itself is a relatively new service that's out there, but there are similarities in other services that we've been using for a very long time. If you think about your phone service, for example, none of us as individuals have the means to create all of the infrastructure necessary to make a phone call. I can't go out and start putting telephone poles in the ground and running wires to all of the houses and configuring all the services necessary to make a phone call. So I use the infrastructure that's already in place. I simply subscribe to the service that is already being offered. That's the same idea with cloud computing. So there's already a lot of organizations that have this necessary infrastructure to provide for me what you see here, three sub-classifications: infrastructure as a service, platform as a service, and software as a service. And you can subscribe to any or all of them. But infrastructure as a service typically deals with accessing more so the hardware, the compute resources that are necessary. So virtual machines themselves, storage, networking components, all of those fall under the infrastructure as a service component. And then platform as a service is generally used for software development. These days, developers require a fairly robust environment, sometimes fairly generally referred to as a framework. It's not just a matter of sitting down at a single computer in a lot of cases and coding up an application. So they need a lot of these other components. They need access to servers with certain software running on it already, such as web servers, messaging servers, database servers, things like that. And they need the development software itself. So platform as a service provides all of this to the subscribers so that they don't have to set up database servers, messaging servers, web servers, and so forth. Software as a service is subscribing to the finished software itself. So that goes back to that customer management software that we just spoke about, wherein you simply do not want to have to bother purchasing, installing, updating, and maintaining the software that you need. You can simply subscribe to it because somebody else has that software. So you can simply access it, usually over the internet, and simply gain access to the software in that fashion rather than installing it in your own organization. So that's the whole idea behind cloud computing, taking advantage of the infrastructure that's already in place by other organizations and accessing these features in the form of a subscription. Cloud computing overall has been divided up into three primary cloud service models, and we'll go through each of them in a little greater detail. But we see here IaaS, which is infrastructure as a service. This is typically targeted at the IT managers, not so much the end users. Then we have platform as a service, or PaaS. This is targeted more so at your IT developers and those who deploy software. And finally, SaaS, or software as a service, which is targeted at the end users and not so much the IT admins or the developers. So looking more closely at IaaS, infrastructure as a service, this is typically concerned with the IT compute resources on which the other cloud services run. Those resources are available remotely over the network. But a perfect example of IaaS is a virtual machine. You do have to have some kind of server to host storage or host an application. So the virtual machine itself provides that infrastructure. Now, at a more basic level, of course, it's the physical server itself on which that virtual machine is running. But as a customer, you're not really concerned about that. We just want to be able to create a new virtual machine. The provider manages the hardware that ultimately drives that system. So, virtual machines, storage, virtual networks, all of those would fall under the category of IaaS. PaaS, platform as a service, again, typically targeted at the developers. Developers these days need a fairly robust environment to develop their applications. They need to test them. They need to deploy them. They need to make sure that they are going to support the needs of the users. So you can certainly create your own development environment within your organization, or you can simply subscribe to it in the cloud. They will provide the necessary virtual machines. They will provide all of the necessary services, such as messaging or database, things like that. And they will even provide a means to test and deploy that application. So this way, we can simply subscribe to everything that is necessary and move the entire development environment into the cloud. So it's all done using these remote resources. So again, it's primarily targeted at your developers. For software as a service, this is specifically for the end users to be able to perform particular business tasks. The service is delivered remotely over a network, but the users can use any type of device. The user device requires only a thin client, which means they only have to have connectivity to whatever is supplying the service. Now, users may have limited application configuration settings, but in a lot of cases, that is exactly what you want. You don't want the user to have control over the configuration. That's done by administration. So this way, they gain access to their application. They can't disable something that they shouldn't be able to, or enable something that they also should not be able to. You can control its configuration. So again, in a lot of cases, that's very desirable. But all of them can be put together. You can have any or all of these services as part of your subscription. You don't You don't generally go in and say, I want an SaaS subscription. It really just comes down to what you use. And again, with all cloud services, you only pay for what you use. So if you decide, well, we do need some infrastructure as a service and some software as a service, well, that's perfectly fine. You don't have to have that platform as a service, for example. You can leave really any part out. You can add any part in at any time. And again, pay only for what you need. Taking a look at some of the core attributes of a cloud computing service, we see here elasticity, on demand, provider pooled computing resources, metered service usage, and broad network access. And again, we'll go through each of these individually. But elasticity, to begin, this refers to the ability to very rapidly add what's referred to as provision and or remove, deprovision resources and or services as needed. And this is a really nice feature, and a very common example of that is a virtual machine itself. So if I have my subscription through to my cloud service provider, I can simply create and configure a new virtual machine literally within minutes. It does not take the servers very long to create a new virtual machine. They have a number of pre-supplied images that can very quickly create a new system. So you can provision a new one anytime you need it. Similarly, if you determine you no longer need it, you can deprovision it, and that is entirely up to you. So it is very flexible, hence the term elasticity. On demand, cloud services are available 24 hours a day, 365 days per year from anywhere given network connectivity. So basically, as long as you have access to the internet, you have full and complete access to your cloud computing environment. There are effectively no business hours when it comes to cloud computing. Provider pooled computing resources. A cloud provider simply acquires and maintains all of the computing hardware on which the cloud services run, and you share that amongst all of your customers. So if I'm the provider, it's up to me to acquire all of the hardware. I need to be able to support all of my users. But from that point, it would be certainly far too expensive if I were to dedicate physical servers to each of my customers. So they all share access to a physical host machine for something like virtual machines, for example. So that's the whole idea behind pooled resources. Customers share the physical. Now, most providers do give you the option to have dedicated resources as well, but of course, they would be more expensive. So the pooled typically helps to save on money. Metered service usage allows for the subscription fee to be based on a billing model that is per use. So in other words, you only pay for what you use. Typically things like the amount of storage space you use and or the amount of network bandwidth consumption will determine what your bill is each month. So again, you do not pay for what you do not use. Broad network access, this means that in essence, the cloud services can be accessed from any type of device. There really isn't any limitations there. If the device itself can access the internet, it can in turn access whatever storage, whatever service, whatever application is available as part of your subscription. So desktop, laptops, mobile devices, any kind of tablet or smartphone, all of those are able to access the cloud services environment, again, provided they have internet access. There are several key technologies that have both enabled and continue to drive the development of cloud computing. Now, we see them listed here, and we will go through them individually, but effectively, it is the cloud data center, virtualization, cloud application programming interfaces or APIs, cloud storage, and cloud database that have enabled us to get to the point where we are today. So the cloud data center, to begin with, this provides the scalability and the reliability required for cloud computing. The providers, particularly the larger scale ones, are organizations such as Microsoft and Amazon and IBM, very large organizations with, for all intents and purposes, unlimited resources when it comes to being able to supply for a single customer. You can really have as much as you need. They tend to have them strategically located as well in cost-effective areas so that you can find services that are physically close to you. And these days, it is trending toward a more modular data center design so that it's not all centralized on one single collection of hardware, if you will. Parts can come and go, let's put it that way. So you literally can have, let's say, an application running on a particular virtual machine. That virtual machine could really be anywhere and can very easily be relocated to somewhere else in the event that the hardware that was driving it failed. So these modular designs make them very portable, if you will, and very reliable because, again, the amount of resources that they have at their disposal are so much higher than what most organizations are able to obtain on their own. Now, virtualization is possibly the most important technological driver in cloud computing, and it is simply the ability to have multiple virtual operating systems running on a single physical computer. The hardware these days is capable of so much more than what it was, let's say, 15 or 20 years ago. So back then, if I wanted 5 servers, I would have to purchase 5 physical computers. These days, I need only purchase one, and I can install multiple operating systems on that single physical computer. That's the idea of virtual machines. So if I want more servers from a cloud type of environment, they just fire up additional virtual machines. From my perspective, it doesn't matter. It does everything a server does, and it provides for me all of the necessary services. It just is no longer running in my organization, but I can access it just like any other server. Even within your own organization, if you do have multiple virtual machines, you are much more efficiently optimizing your resources because, again, you don't need to buy 5 physical computers for 5 servers. You only need to buy one. Now, with respect to cloud-based services and virtualization, it's generally offered under a pay-as-you-go pricing model. So you only pay for what you use, which is very nice. You don't have to buy a package, for example, of 10 virtual machines if you only need 2. So it helps to keep your costs down even further. Now, Cloud APIs, or Application Programming Interface, serves as this layer between users and the cloud services and resources that they require. But I do want to clarify that the term users here, for the most part, refers to developers, those who are actually building the applications. The most commonly used API architecture these days is what's known as representational state transfer, or REST for short. So as an end user, this really doesn't mean much. But if you are a developer, or if maybe you have a team of developers that you manage and you're considering a move to a cloud type of environment, you would certainly want to know that they do provide the REST architecture for your developers, and cloud services absolutely do. It is the means by which they can access the resources they need. So, for example, if they have to connect to a database to obtain information for their application, the REST architecture is how they can do that. So it's a much more lightweight and consistent type of architectural environment and fully supported under cloud services. So again, it allows you to move your development environment into the cloud rather than having to maintain all of the necessary physical architecture in your own organization. Cloud storage is typically accessed using any kind of web-based HTTP interface that is offered by the cloud service providers. So again, coming back to the developers, they might be developing an application that has to gain access to data. Well, the data is up in the cloud, and their application, as long as it has internet connectivity, they can use standard HTTP requests to access that data. And with it being in the cloud and accessed over a web-based interface, it doesn't matter where they are or where the application is. As long as it has access to the internet, it has access to the data. Cloud database, typically in most environments, cloud computing isn't well suited to what's known as relational databases. This is where we have records in one table that are related or connected to records in another table, and that can go on and on and on and on. Those are a little more better suited to an internal environment still, simply because of limited scalability and integrity with the structured query language based language. That's what most relational databases use. But there are also these non-relational databases wherein we're not concerned with any kind of connection between table 1 and table 2 and table 3 and so forth. You may just have a single table that stores some customer information, just name and address, phone number, email address, things like that. And that's all you need to store. That's what's known as a key value type of table, wherein the key is the field, such as a person's email address. The value is the actual address. So it's more item oriented, just focused on a particular and specific attribute, if you will. So these scale very easily. You can just grow and grow and grow and grow the number of records. So this way, you can have non-relational databases in the cloud type environment, and you can just store literally millions upon millions of records if necessary. So it's just a lot more easy, again, for things like your developers to access that information through whichever means they need to. But that data, again, is accessible from anywhere, and in a much more easy or simpler format than accessing a relational database. There's a relatively new approach emerging now for cloud computing service models, and that's what's known as XaaS. And the X actually stands for anything as a service. So any IT service that's hosted on a provider infrastructure can then be offered as a cloud service model. It's still remotely available over a network like any other service, so it just comes down to what kind of services you might need. And typically what you'll find under XaaS are the following: data as a service, storage as a service, communication as a service, and business processes as a service. So for data as a service, the data is available on demand and encrypted in transit. So it might be the case where you have maybe a single application or even multiple applications, but they're all accessing a single copy of maybe a database, for example. So the geographic location is irrelevant as long as there is internet connectivity with the devices that are accessing it. They all access that central copy of that data. So they can use anything, it doesn't matter, but it's that same single version of a data file that everyone is accessing. So all that is required from the perspective of a customer is simply just data. They don't need virtual machines. They don't need additional storage. They don't need websites. They just simply need access to data in a very centralized means, but accessible from anywhere. So this is where it might be useful to investigate data as a service. Now, storage as a service, a lot of document management type of companies might offer this as a service, wherein it is simply off-site data backup storage and disaster recovery. A lot of companies need, even with respect to governmental regulations or any other kind of laws that might be in place, they need to store their data off-site, somewhere other than their own organization. So if they don't have that, then of course you can subscribe to somebody else's services. You can have effectively as long a term retention as you need, but they do offer this simple storage as a service. There's a backup. You guys will have a copy for however long. So again, document management companies are good examples of those. Communication as a service. This, of course, is the communications infrastructure that we are all fairly familiar with, typically telcos, telephone companies. So the infrastructure is hosted on the provider equipment. We can still remotely access that infrastructure over our network, but the complex equipment setup is handled by the provider, as is fault tolerance. It's up to them to make sure they are providing us that higher level of fault tolerance. And it's pay as you go, like any kind of other subscription based service. So voice over IP is a very good example of this. Most businesses don't have the infrastructure to implement a VoIP system. So you simply subscribe to those who do have the necessary infrastructure. And finally, business processes as a service. This is outsourced business process automation. This typically relies on the existing cloud infrastructure services such as SaaS, PaaS, and IaaS, which are let's call them the standard cloud models. But the business processes are delivered over the cloud, and the complexity of those processes and their automation runs elsewhere. So this allows for a faster time to market, and any kind of regulatory compliance is still handled by the provider. So if you do have a fairly complex environment that requires a lot of automation, then this can also be provided by a cloud service model. So, again, it's up to you, of course, if you require these services, but a lot of new services are coming into the cloud environment all the time. So if it's something that you think might be too complex for your own organization to implement, then chances are you can find it as a cloud service from a provider somewhere.